PAC194 and PAC195 are power monitor device families with up to 4 channels, with current sense amplifiers and bus voltage monitors that feed high-resolution ADCs. Digital circuitry performs power calculations and energy accumulation. This enables energy monitoring with integration periods up to 1 year or longer. Bus voltage, sense resistor voltage, and accumulated proportional power are stored in registers for retrieval by the system host or embedded controller, CPU, MCU. The sampling rate and energy integration period can be controlled over SMBus or I2C. Active channel selection, single-shot measurements, and other controls are also configurable. The PAC devices use real-time calibration to minimize the offset error. No input filters are required for this device. The purpose of this video is to introduce the new PAC194 and 50 generic library. This library was designed to be easy to use because it has a high-level API that offers the user access to the functionality of the device without requiring a detailed understanding of how it works. The PAC library is also easily adaptable for various MCU platforms with minimum adaptation effort and without changing the high-level API. The library interface allows the simultaneous use of multiple PAC194 and 50 devices in a multi-threaded mode and can operate in an either blocking or non-blocking mode. The PAC194 and 50 library contains functions for real-time reporting measurement such as energy, charge, power, and voltage, and functions for configuration and control of the operating parameters such as sampling rate, channel polarity, and others. The library was designed to allow the use of multiple devices and has an initialization function that must be called for each instance. For I2C communication with the PAC devices, the library uses the platform's dedicated I2C driver and can be easily adapted to either an event-based communication by registering a callback function or to a non-event-based communication by polling the state of the communication sequence. The PAC194 and 50 library is designed to allow the users to register their own callback function in order to receive notifications from the library. PAC194 and 50 library is an easy-to-use library that contains a set of platform-independent files that implement the access to the device's functionality and another set of files that represents the platform's adaptation layer. This layer contains the target platform-dependent code, the I2C communication shim layer, and the resource access synchronization functions, mutex. These are the platform-independent files. In order to adapt the library to a specific platform, the user does not have to modify them. These are the platform-dependent files that contain the platform adaptation layer. The user can replace the communication and mutex functions inside the wrappers with his platform-specific functions. This video presents an example application for a 32-bit Microchip PAC32 MCU platform. Now we are opening the MPLAB XIDE project that contains the library and the example application. We can see the app compiling and the tool will download it on the target platform. The application starts sending messages on the COM port. These messages can be captured by any usual console application. And now the same application was ported and deployed on an 8-bit Arduino Uno platform, as you can notice in the video. We are opening the Arduino IDE project that contains the library and the example application. We can see the app compiling and the tool will download it on the target platform. We can see that the app starts sending messages on the COM port. Both application examples can be downloaded from the Microchip website. The changes required to be made are located only inside the target platform adaptation layer files of the library. In case of harmony-based platforms such as the PAC32 platform presented, the communication wrapper function passes the parameters to the I2C driver functions. For other platforms, further adaptation may be necessary. As you may notice in this example, for the Arduino platform was necessary to add a shim layer between the native Arduino API for read and write functions that translates the parameters and the data buffers in the expected format by the Arduino communication functions. The Arduino platform uses the library in blocking mode because the platform's I2C driver does not offer support for simultaneous transfer requests with multiple clients, and the mutex functions become empty functions. There is no need for access synchronization because the application is single-threaded and the library works in blocking mode.